Okay, the TLI checklist just came up here. I've got a good TLI pad here. Let's go ahead and go through the steps here. Translator inject, check. EDS power on, verify. Check. EMS function off, verify, check. I'm going to go ahead and let it do the DV test here. Basically, standby, function DV, EMS mode normal. Then we change this to DV set. 1586.8. Back to DV and DV test. All right. Minus 20, 28, plus or minus 20. Looks good. Standby, mode off. Okay, we're going to go to DV set. I'm going to use this to kind of cheat and automatically set this to 10,000. We'll set the TLI DV, which is going to be DVC 10,499.1 right here. Okay, EMS mode to DV. And it wants a GDC align. Guess we can go ahead and do that too. FDAI select 1. I'm going to go ahead and turn the ordeal off as well. Add to set thumb wheels to FDAI attitude. So, let's see, about 150, 155, roll 180, all is 0. Okay. FDAI source attitude set. IMU. We're going to null these error needles. Just using the attitude set control panel to do this here. Right clicking for 10th of a degree increments. There you go. They're all nulled. GDC, GDC align. Okay. And then source back to CMC and FDAI select back to 1, 2. I'm going to go ahead and put my ordeal back on. Cool. Which has drifted a little bit, which is normal. Okay, let's see here. So we're going to go ahead and go through the list here. DAI skill 5.1. FDAI select 1, 2. Check, 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 check. All those are done. Now let's turn this off for now. So these are just checking that the logic battery A breakers are closed. I'm sorry, logic breakers are closed, arm breakers are open. Okay, THC power on, translational hand control power on, rotational control power to AC/DC, direct to main A, main B, launch vehicle indicator, GPI switch to S2, S4B, which is right here. Launch guidance switch IU guarded, which is right here. Direct ullage, main A, main B, breakers closed. DET stop, reset, and we're going to set it to 51 minutes. There we go. Sequential logic 2 on. Pyro A, sequence A, Pyro B, sequence B closed. Those are down here. Pyro A, sequence A, Pyro B, sequence B. Now, it's just waiting for time base 6. So time base 6, according to the pad here, is 2 hours 40 minutes. So what I'm going to do is I'm going to go ahead and go to about 2 hours and 39 minutes here. Just a little bit before that, just a little bit of time acceleration. 10x is what I'm using, that way the vehicle doesn't go, start firing its thrusters or anything like that. And it's on the nighttime side of Earth. So at this point, time base 6 is basically when the launch vehicle digital computer in the instrument unit knows when to start the sequencing and all the stuff for TLI burn. Basically everything it needs to do to relight the S4B to go TLI. But this is just a rough estimate, or it's pretty close, usually within 30 seconds or so of the actual time it would send up to the crew. So that's what the S2 SEP light is for. The LVDC sends a signal to the command module that lights the S2 SEP light, and that's going to start. That's going to be 9 minutes and 38 seconds before before TLI. Go a little bit further here. So now it's just a waiting game. So this is going to kick on. We're going to switch FDAI2 to orbital right here. But when this light comes on, that's our signal to get started. So when the light turns off, then we're going to start the DET. The light turns off with 51 minutes before TLI. So the estimated time was 2 hours, 40 minutes, 43 seconds. We'll see how close it was. Oh, there it is. About 2 seconds late. And then when that light goes off, we're going to start the DET counting up. There it goes. DET started. Spacecraft control SCS confirmed. Check launch vehicle tank pressure, which are these down here. Got the S4B oxidizer and S4B fuel pressures. Making sure the uplink telemetry for CM and IU are both in block. Now we're going to wait for time base 6 plus 6 minutes, 38 seconds, which should be 57 minutes on the DET. I'm going to go ahead and fast forward this 10x just to get up to that point. At this point, the S4B is doing all the pre-pressurization and everything for the tanks to get it ready to ignite again. Alright, there's 57 minutes. We're going to go ahead and do a verb 37 enter, 47 enter, starting P47, which is just basically monitoring velocity. And it's accumulating any acceleration we have in the spacecraft into the state vectors. The program behind there is called average G, and that's what basically adds whatever we're burning into the current state vector. Verb 46 enter. That starts the S4B, or excuse me, the Saturn DAP there. And at DET58, we're going to call noun 62. That's going to display a few things, like our inertial velocity. So noun 62, enter. Current inertial velocity right there. That's our altitude rate. I'm sorry, yeah, our rate right there. And this is our basically our perigee altitude right here. So we're going to turn TVC servo power 1 to on, thrust vector control power on. That's if we needed to overtake and manually control TLI, we could do that. And then EMS mode normal. S2 step light is back on. Ullage has started, which you can see right there. The apps thrusters are firing ullage, they're ullage motors. And at 59:42, S2 step light should turn off, and all these other ones are all like the fuel leads and everything like that for the booster, basically prepping itself with all the fuel settled in the tanks to ignite again. Now later missions, J missions, they had to actually program 15, which would not only do what program 47 is doing in the background, but then it would also display things like their inertial velocity, things like that. And they could put in their time-based 6 time and all that stuff, and it would compute all this stuff automatically for you. For Apollo 8, it was simply program 47. Okay, the S2 step light is off. The fuel lead is probably started here. Ullage completion should be right about now. Yep, there it goes. And get ready to light. There it goes. And we're burning TLI. So that's basically it. As you can see, it just starts getting a little bit of yaw attitude excursion there, which is completely normal. And we are burning. I didn't mention it before, but if you noticed, the FDAI was about this attitude right here, 179.45.1, approximately at TLI ignition. That was our attitude, but we're slowly still pitching a little bit because this is not an inertial current. Altitude rate essentially, and our perigee altitude of course is increasing as well, and our inertial velocity is increasing. we're looking at approximately about 35,569 for inertial velocity at cutoff, which will be indicated right here. Total burn time is 5 minutes 18 seconds, so this should be roughly 5:18 at cutoff. See, we're doing about a little over 1G also. Those were yawing a little bit out of plane. In the TLI checklist for 8, you'll actually see there's a psi value for this that actually just shows what your yaw over time becomes over the burn. That way, if they need to manually burn TLI, they can say, okay, this much delta V left at this much time, I should be at this yaw, this pitch kind of thing. So they would be able to increment it at manual TLI burn if necessary. Later missions also have this as well. Should have about a minute left of the burn. See that inertially we're still holding kind of close to where we were on the FDA eyeball here, but of course that yaw factor's in there. This is displaying the ordeal still. Get about a G and a half. Here you can get the checklist in the external MFD and 3D if you wanted to as well. There's cutoff. Verb to freeze display. 35,569, 35,577. Pretty darn close. Anyway, so that's how you do a TLI. And for Apollo 8.